Welcome back to the another session in series of learning design and analysis of algorithms. And this video is to understand about growth rate of a function. Okay, growth rate of a function. So basically, if you refer the textbook or if you refer any e-books also, you can see these two terms: growth rate or order of growth. So let's understand the concept of this. Before of this growth rate, there was the another video with the name of asymptotic notations. There we were taken two functions, f of n function and g of n function. So f of n function is algorithm what you are writing. G of n is the growth rate that you are applying many comparisons on your program. Okay. So now the order of growth of a function always will be this. Order of growth is something this that big O of 1 means what? 1 comparison. Okay. Log n means n by 2 comparisons. N comparisons. N into n by 2 comparisons. N square comparisons. 2 power n comparisons. N factorial comparisons. So this is what the growth rate is defined as. Growth rate is the function or the input through which we will be having the number of comparisons starts from 1 to many. If you are writing any algorithm, let's suppose that searching a number. Okay, take the example that searching a number. So when you want to search a number in the given list, so probably we'll be taking the linear search into consideration. Okay. So when you are searching a number in linear search, in the first comparison, if you find the element, the element what you are wanted to find, if it is appeared in the first place of it, then this is what the best case we used to call, right? And this is what the average case we used to call. That means what? Finding the element what you wanted to search is appeared or it is available in the middle of the n. For suppose if I have list of 5 elements, okay, so in 5 elements my key element, the element what I wanted to search is available in the first place. So that is what, how many comparisons I have taken? One comparison, single comparison. So I found the element in the first place. Now that is what your best case. And order of growth is what? Big O of 1. If I found the element in the middle place, in this place, if I found my key element in this place, then I don't want to go for these elements. Why? Because I found my element here, my algorithm will function up to here. It will not go to the next statement, right? Now my order of growth is what? N by 2. Big O of n by 2. If my key element is found in the last place, then my order of my growth rate is what? Big O of n. Okay. Now you can understand much with these examples, I believe. F of n, it is equal to, f of n is equal to n cube n square plus 5. Among these terms, highest time complexity will be the total time complexity of this function. Okay. Now, what is the highest complexity? 2 n cube means what? You have to take n cube comparisons. N square means you have to take n square comparisons. 5 means you have to take constant time comparisons. So what is the time complexity of this function? What is the time complexity of this function? The maximum time which is taken to execute the maximum comparisons. That means the maximum comparisons of what? Constant is symbolizes with 1, it is n square, it is n cube. The maximum is what? N cube. So the total time complexity of this function is what? Big O of n cube. Okay. Now let's take other example. I do have two functions, f of n is equal to g of n is equal to. Now if I wanted to find the time complexity of these functions, so what I am going to do is time complexity t of n is equal to f of n plus g of n. So now what is the time complexity? I told you in the last statement, that the maximum time taken of maximum the time taken to execute the maximum number of comparisons will be the time complexity of a function. So what is the maximum time taken by this function? N cube. The maximum value is n cube. So the time complexity of this function will be n cube. So what is the maximum time taken to execute this? That is maximum comparison, which is n power 4. So it is n cube. So the time complexity of this function will be n cube. The time complexity of this function will be g of n. The total time complexity is equal to the time which is taken to execute f of n plus the time which is taken to execute g of n is equal to, what is the time of f of n? Big O of n cube. What is the time of g of n? Big O of n power 4. Now again you have both the times, right? So what you have to consider the maximum time which is taken. Now among these two, what is the maximum time? Big O of n power 4. So that is big O of n power 4. So the maximum time complexity is big O of n power 4. This is what the growth rate. Okay. The growth rate is the time which is the maximum time which is taken to execute certain function is the growth rate. Okay. And thank you all.